Hey Valley Middle, welcome back to another math lesson. Let's get started with something fun. Our JFF question is, how many different pizza combinations can Domino's make? If you say 3, you're probably missing the bigger picture here because you could have different toppings and different sauces and different crusts and different combinations of toppings. It's more than 3. That's my clue. All right, let's get to the target. Today, I can complete a function. We're at 1.10c. Here we go. Yesterday we looked at this function table, y equals 3x, and today we have to complete it. And I've scattered some values over here that you can take and plug in to see if you can figure it out. So I want you to pause and see if you can figure out which of these values over here would slide into these empty boxes. Go ahead and pause. Oh, we're back. This one is a pretty easy one because this time they actually gave you the rule. They're saying you take 3 times the x and that becomes the y. So we've got 2, and if I take 3 times that x value, or 3 times 2, I get 6. Same thing here. This one's a little weird. It's a 3 value and it's 3x, so 3 times 3 is going to be 9. We slide this guy in. And then 4 times 3, because that's what I'm doing here, I'm multiplying all my x's by 3, would be 12. And so you can throw that one in. If at any point in time you wanted to take and throw Uncle Fred as an answer into here, you've got some bigger problems that we need to work with. All right, let's try a quick vocabulary review. Remember, this is the domain, y is the range. So domain, range. Domain, range. Are you getting sleepy? Not yet. All right, just messing with you. Here's your first one. When you look at a function table like this, you got to figure out what's going on. And that's my little first thing here. What up? What's happening to the x value to get it to a y value? Then you try to make a rule that would work. When you figure out what you think is the right rule, then start trying it for the different samples. And if it works, you got the rule, complete your table. If not, you have to take and try a new rule and try to figure it out. So here I've got 1 becoming 3. My first thought is add 2. So add 2. 1 plus 2 is 3. My rule is done? No. Remember what I said? You have to try it for all the values. So I'll try it here. 2 plus 2 is 4, not 6. My rule doesn't work. I want you to pause the tape or the video, go back, see if you can find a rule that will work for all these examples, and then when you do, see if you can figure out the values for 5, 20, and 99. Don't worry about n at this point. Go ahead. I'm back. If you said your rule was taking everything times 3, you did pretty well because that's what the rule is. You multiply the x by 3, just like in that last table. So if you have 5 times 3 would be 15, 20 times 3 would be 60, 99 times 3 would be 297. And really what they're asking for over here when they're asking you for what the rule is. That's not the point of our target today. We're just trying to figure out how to plug in values to complete it. All right? The next example. Give this one here a shot. Go ahead and pause it. Now you've got a couple of ideas of how to do it. Go for it. I'm back. All right. Well, the first thing I thought about was, it's like, I see that 16. I think they're like adding 16. So 1 plus 16 is not 16. What? That didn't work. I didn't even try that one. So then I thought, well, I must be 1 less. So 1 plus 15 is 16. 2 plus 15 is 17. 3 plus 15 is 18. 4 plus 15 is 19. I've got my rule so that then I can take and figure out the values. Whoops, this one here is going to have to sit down here because it's not going to slide under. 5 plus 15 will be 20. 20 plus 15 is 35. 99. You got 114. And we've completed another function table. All right, this next one is going to be a little bit harder. why don't you go ahead and pause and give this one a shot. All right, well, my first thought on it was it's multiplying by 2 because I looked at this. 2 times 2 is 4. 3 times 2 is not 9. So get rid of that guy. The next one was taking it times 3. 2 times 3 doesn't equal 4, but 3 times 3 equals 9, so then it works, right? Wrong. It's got to work for all values, so get rid of that guy. What else we got down here hiding? X squared. Let's try that one. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And if you go on down, 5 times 5 will be 25. 20 times 20 would be 400. And 99 times 99 is 9,801. And you've completed your function table. So, the ticket to the show. You'll notice that in this function table that I'm giving you, I didn't just omit x values or y values. Sometimes I've omitted a x value as well. So now you're going to have to look at it, try to figure out what's going on based upon data on both sides or values on both sides and plug them in. So please complete these 2 for tomorrow and that'll be it. Let's do the just for fun question. Whoa! How many different pizza combinations can Domino's make? I was stunned. I actually was looking online and I saw this thing that said they could make 75 million pizza combinations. I was like, yeah, whatever. And I'm President Obama. Yeah. Actually, I was wrong. I found a place online, and I'm pretty sure this is correct, that here's a whole bunch of math here. Bottom line, 105 million different combinations. And that's just going up to like 1 or 2 different toppings. That doesn't even go past that. So basically, the bottom line is you can eat Domino's pizza every day for the rest of your life, I'm pretty sure, and have a different one. But hey, who wants that when you can get a triple cheese pepperoni, the best one in the world? All right, thanks for listening. Have a nice night. Bye.